So we've said there's a function in Lambda called playGame.
So let's
Probably,
write this.
yeah, you could argue it should go at the end because it uses literally everything else, or you could argue it should go at the beginning because it's the first thing that anyone calls. What do you think? Well, you could argue it either way, couldn't you?
Myself, right now, I'm thinking to put this at the very end.
Right. Well, you're in charge, so
Okay.
we'll go with you. Okay, it takes something. We'll come to that in a moment, but it doesn't return anything.
Yeah. That's
Now,
not anything. Okay.
yeah, now what does it take? We've said it's going to be variadic because there could be any number of options, any number of which you
Yeah.
can omit.
So
It'll be
takes some
dot dot dot
number of
something.
Functions.
That's right.
We know.
Suppose we just give this type a name and just call it option. That'll make this easier to read, won't it? So we'll just say we take variadic option and we'll need a name for that parameter. So let's name it opts, let's say. Yeah, other way around. I think this is the only logical way to do it. Name first, then type. But apparently every other programming language does it differently. I don't care. This is right. So that's great. We haven't defined option yet, but we will. So what are we going to do in playGame?
So we need to create the game. That's the first step.
Yeah, you know how to do that.
Yeah, so we have new game. So our game.
Yeah, that also returns error.
Right. And we need to have error.
Just for reasons of paranoia, you know, but
yeah,
but that's good,
exactly.
isn't it? When I was working with Parish on the refactory, we had something similar, and he said, I'm always paranoid by default. And so that's a great default setting.
Yeah.
If the error is not nil, then let's return it. Fine. So
And
that sort of
know...
suggests that we return error, doesn't it? But we didn't.
Yes, exactly. Yeah.
We didn't receive that. Either in, you know, we didn't think about receiving it in main, and we didn't receive it in the test. I think.
So yeah, what do you think? Yeah?
Well, you tell me, and then I'll agree with you.
So maybe for example, we can create, instead of creating we could create like a run function or play, then handle error, and then in main we can, for example, log this error, catch this error, and log if we are getting this error. Just first idea.
Yeah, I think that's reasonable. But I also think, yeah, wait. Let's, you know, these variadic options that we're going to pass to playGame, they have parameters, so they could be wrong. You know, suppose you tried to supply an output writer, which in fact doesn't exist, or something. You know, that could be wrong. So we definitely need to return error from this, don't we? In fact, that's usual with functional options. If you have options, then they could be invalid, so you need to return error. So, yeah, I think you're right. Let's just return error here. That's the logic of what we're doing is sort of inexorable, isn't it? It's writing itself, which is good. Okay.
Okay.
We have the G, and in fact we have all of the rest of the code for playGame. It's already in main, isn't it? Let's just lift and shift.
Oh yeah. So basically this is already implemented. Okay. And here is our logic.
Yeah, actually the print statement too, isn't it?
This one, I mean, yeah?
Yeah. Even that doesn't belong in main. That's part of the game.
So.
Great. And I think another another sort of part of the rationale for doing this series is because every time, as we've said before, most people's experience of a given code base is coming to it when it's already fairly complex, isn't it? More than one package, lots and lots of stuff. They never really see how it got that way. And you might quite reasonably assume, from watching coding videos and things like this, that basically this is what programmers do, is they start with this. But that's not the case, is it? I mean, maybe some people do. They just write down the exact correct architecture first go. I definitely don't work that way. I don't think you do either. What we probably do is just a very rough first cut, isn't it? Just in main, just to get something working or doing anything. And then gradually add more bits onto it, always trying to have a working, shippable game, even if it's a rubbish one. And, tests and things like this. And the end state is more like this, isn't it? So, but I think that's sort of a bit of a dark secret in the software industry. I don't think anyone ever sees that bit. So people might well not be aware that's what's happened. And they'll see it in this series, as they'll see me do exactly that. If you watch this yourself, you'll see where it all started, which was just writing func main. Let's print some stuff, do some stuff. So that's quite nice. I think it may help people, if they feel looking at this, well, I couldn't just sit down and write this program. Well, relax, neither can I. Neither can Jakub. We need to evolve to this point.
Yeah, and gradually, step by step, actually, and frequently by trial and error.
Yeah, exactly. If you break it down into small enough steps, you can basically do anything. Just a matter of confidence at that point. So, okay, so we created the G, printed out the message. Now, that's not going to go to the terminal this time. This is going to go to our output writer, isn't it? Which that must be on the game, I think, mustn't it? Feels like it's got to be on the game.
Here, basically, enter trans settings, one second. Yeah, so let's move it.
So it becomes fprintf again.
But
so what would make sense here? Something like g.output?
Like this?
Yeah, instead of the W. So the writer we're writing to is g.output, and then we send it that message. It's just a fixed string, in fact, but that's okay. We have it.
Yeah.
So that's makes sense for output to be unexported, doesn't it? Because the only way you're going to set it is by passing this functional option with output.
Yeah.
So that's okay. And similarly, we could change the parameter to g.displayState at line 60, but we don't really need to, because if the G already knows its output, we needn't pass anything, need we?
Yeah.
You can just remove it.
Basically, std out.
Which feels right, and the same for read thrust. So we'll also know our input. And you sort of feel like, don't you kind of feel like the printf should be some method on the G? Like it seems the wrong level of abstraction compared to everything else, doesn't it? Suppose we had some method like g.print welcome, or display start message, something like that.
So you suggest implement this right now, quickly?
Yeah, we can do that. So it's just that one fprintf call, but the fact that no one else needs to take output because they all know it. This should just know it too, shouldn't it? It's a value method. Yeah. What about display welcome?
Message.
Yeah, that'll do. Takes nothing, returns nothing, and it just does that. Great. So we don't have an explicit test for display welcome, but it will be tested, won't it?
Display welcome. G.
Exactly. G.output. That's right. Doesn't exist yet, but it will.
So then we can call this here.
Yeah.
Display welcome.
Yeah, compiler is angry because you broke display state and read thrust because they still expect to take something, but they need
different signature. Yeah. Then we have io.Writer, which will be our G.
So we won't need to pass anything, will we? Because if the G knows its input and output, then that's it. Great. All we need to do is change those method signatures. And I've seen people kind of, be a bit alarmed about this sort of thing. Like, they make some small refactoring and it suddenly they've got 100 compiler errors. Of course. I mean, if you change the signature of some method that gets called everywhere, of course that's going to happen. But it's okay. Doesn't mean you did something wrong or that you shouldn't do refactoring or whatever. It's like, just, how would you say it? Just relax. The fact that you have 100 errors from one tiny change doesn't mean you have 100 problems. It probably just means you have one problem 100 times, doesn't it?
Which is easier to fix.
Yeah, and in many cases your IDE can just fix it for you. So fine, so we can go to display state and tell it not to expect any parameters anymore. That'll fix that, and the same for read thrust.
Display state. Hold on. Display results. So where we have displayed state. Okay, so we are not taking io.Writer. So we need to refactor this to actually G.
Yep, G.output would be right, yeah.
But then display state. And the same we have for read thrust. So here will be output. G.
Wonderful.
But yeah, and as well delete this.
Great.
Okay.
That definitely looks nice. Oh, and display result also doesn't need to take anything anymore, does it?
Yeah.
Usually a sign you're on the right lines when you're chopping out a bunch of stuff like this.
G output.
Great. Now let's add those fields and we'll get rid of a lot of compiler errors at once, won't we?
So here let's add, right? No, this is state.
Hold on. So this is finally something on the game that's not the state.
Yeah.
Which is nice.
So game, and here will be our output, right?
Yeah, we can just have output and input. And that's all we need for now.
And will be io.Writer.
Yeah. Don't you love io.Writer?
Yeah.
It's just, well, io.Reader is my favorite thing, but io.Writer is a close second.
you fall in love with io.Writer reader the longer you work with Go.
Yeah, that's right. You know, one of the nice things is you can travel anywhere in the world or meet a Go programmer anywhere under any circumstances. You can just go to them. io.Reader, it's great, right? They're like, yeah, I love that too.
Let's do io.Reader for our input, right? Or I don't know if we will need this. Output. We don't have input yet. So
Fantastic, yeah. This is looking really nice, isn't it? So almost everything is done now. The only bit we haven't done is this with input and output, isn't it?
Yeah.
And we can sort of feel our way towards that because, oh yeah, we'll fix that. That doesn't take anything anymore. Great, so we're saying there's some function with input, for example. Wait a sec, actually, before we do that, we need to actually do something with those options, don't we? So inside play game, we have opts, which will appear to us as a slice of option. So what should we do with that slice?
We will need to iterate over and apply these options, right?
Yeah,
to our this game.
Yeah, that's what we do with almost every slice, isn't it? Just range over it.
Yeah.
So we can do that, and we're going to be setting things on the G as a result of that. Mm-hmm. So we sort of need the G beforehand, don't we?
Yeah.
So we need to say, give me a new G, and then I'll set some options on it. So now we can write the for loop.
Yeah, so we create basically this default one, new game, and then just in case we are applying the functions to this, yeah. So basically...
It's always easy to write loops in Go because you don't have to remember which keyword it is that you need. There's only one. We can range over opts, and then for each O, what are we going to do with it? Well, it's a functional option, so that implies this is a function we can call. So we can call it.
Yeah, so we'll be...
Does it need to take anything? Well, the G would make sense, wouldn't it?
Yes, yes. So we are getting G as parameter.
In fact, because we're asking it to set something on the G, we need to pass it the pointer to the G.
Oh, yeah. So basically here will be...
we want to take the address of it, that's right. Well, the sharing operator, as I like to call it. It's rather lovely, isn't it? So, great. So does that return anything? Well, it could return error, couldn't it?
Yeah.
And if it does, that's easy. We can just return that error from play game. Exactly. Very nice. Almost all Go programs contain this loop. You could even get the IDE to fill it in for you. So that's great. And we've done that. So the nice thing about this is that now we know what type option is, don't we? We could write that type definition.
So our option is basically...
We're saying type option is a func every Go program contains this type definition, or something very similar.
Yes.
Type option is a func which takes
basically our pointer to our game.
Pointer to game, that's right, and returns error. Great. So we've used the options, we've defined the option type, and the only remaining question is, well, where do we get one of these funcs from? Because you could just make the user write it, couldn't you? You could make them pass in a function literal that takes the pointer to game and returns error and sets the thing they want, but we don't need to make them do that. We can do that for them. we can write some function which returns that function, isn't it?
Yes.
Sounds a bit nuts, but it's very Go-like. First-class functions in general are very Go-like. So we already know its name, don't we? We called it with input, for example.
With input, yeah.
So there's some function with input. We can write this.
Here we go. With input, with output. Right.
Yeah, let's try input first.